me to do this. Okay. Every time when you have a question like this, more often than not, they will not give you like conditions. If they don't give you conditions, always make sure that you have a triangle of some sort. Ne?
Yes, sir.
Okay. Make what sine 62 is. Ne? Sine 62 degrees is. Ne? We need to find that if we are told that sine of 2 degrees is equals to k. So what you want to do, you want to take this information and put it in this triangle here. Then this here will be 2 degrees, right? So what is sine? K, every number is always over 1. So sine of 2 degrees is opposite over hypotenuse. So that is k over 1. Question is, how do we find the last unknown side, this one? How do we find this unknown side?
Pythagoras.
Sorry?
Pythagoras.
Pythagoras. So let's use Pythagoras to get this side. Let's assume this is some x because this is hypotenuse, that's the opposite. So we can use Pythagoras. So that will be r squared x squared plus y squared. Where your r is 1, your x is what you do not know, your y is k squared. And then x squared becomes 1 minus k squared, and then x just becomes square root of that. You don't have to do plus or minus because this thing is not like in quadrant number 2 or what. You consider it to just to be in quadrant number 1. So the value of x there is root of 1 minus x k squared. Are you happy? Are you happy there? Are you happy?
Yes, sir.
Yes, sir.
So now, this is 2 degrees. I always advise my students that also get this angle here. This angle here will be 88 degrees. Do you guys agree?
Yes.
Okay. So now, with that being said, when you want to simplify this, you write it in terms of the following angles. Yeah? You can expand this in terms of special angles. You can use boundary angles. You know what boundary angles are, right?
Yes.
Yes, sir.
Boundary angles. Which is like 90, 180, 270, 360. Or you can use given angles. By given angles, I mean the ones that you are given. Right? So you want to write this 62. You can see here, you don't have a 62 here in this triangle. Do you see that? Do you see that? You don't have a 62 in this triangle here. No? You only have a 2 and an 88. So now you're gonna have to figure out, how do I write 62 degrees, either in terms of special angles, boundary angles, the given angles. Once you give it a try. 62 degrees is the same as?
Sine 60 plus 2. Can't we say that?
62 degrees is the same as saying sine of 60 degrees plus what? Plus 2 degrees. Are you guys happy there? Are you guys happy there?
Yes, sir.
Yes, sir.
Everyone. So now, we now know that 60 is a special angle, 2 degrees is in the triangle, so we can deal with that. So what, this looks like a what? What does this look like? This setup, it looks like a what?
Compound.
It looks like a?
A double angle, I mean.
It looks like a double angle.
Compound.
A compound angle,
Double.
sorry.
Compound, not a double.
Compound. So now we're going to expand this into a compound format. All right.
Sorry, I didn't understand that.
So this is sine of 60. You can get this in your books. No man, in your thing, formula sheet is there. Plus sine of 2 cos of 60. And then sine of 6 is a special angle. If you punch in the calculator, you will see that is √3/2. Cos of 2, you're gonna get it from this here. Cos of 2 is adjacent of hypotenuse. So your adjacent then becomes 1 minus k squared over 1 plus sine of 2 you were given to be k over 1 basically, k over 1. Cos of 60 is a half. And then you simplify these things. This is √3 root of 1 minus k squared over 2. On the other side is k over 2. They not really care much about this. You can just leave it here, really. Yeah? Or you can go further and just say the denominators are the same, or they're the same. Then you can add the numerators. That's still fine. Are you guys happy there? Are you guys happy there?
Sir,
Yes.
where it says sine 60 plus 2, like at the beginning of the sum,
Yeah.
why couldn't you just derive it as sin 2 and then make that equal to k?
No. So we can't do that because that's a very good question that you use there. You can't say this is equals to sine of 2. No. Remember, 60 degrees is not a boundary angles. You only apply reduction formulas on boundary angles. I'm glad that you asked that. Let me show you when do we do that. Ne? Sine of 182. How can I write sine of 182 in terms of 2 degrees and in terms of 88 or 88 degrees? It's up to you. What is this? Sine of 182 degrees.
180 plus 2.
180 plus 2. So this is sine of 180 plus 2, right? So now, do you see then that 180 is a boundary angle? So I can apply a reduction formula here. Andy, so do you see that?
Yes, sir.
So if it's 90, 180, 360, whatever, you can apply a reduction formula. Are you happy?
Yes, sir.
Okay, now let's look at this board. So with that being said, which is quadrant number 3? Remember, this is quadrant number 3. And sine is what? Is positive or negative in quadrant number 3?
Negative.
Negative.
So that would be negative sine 2 degrees. But then you know what sine 2 degrees is k. So that is negative k. Are you guys happy there? Are you guys happy there?
Yes, sir.
Yes, sir.
Let's go deeper. What about sine of 4 degrees? What is sine 4 degrees?
It's, can't we say sine 2 bracket 2, like 2 times sine?
Exactly. Okay. So guys, you're gonna have to incorporate a lot of this information. So 4 degrees can be written in terms of a double angle. So this can be expressed as sine of 2 there. Why do I do this? I know this is a double angle, né? So I can expand it. Remember double angle?
Mhm.
I'm still here, guys. Let me swap my Wi-Fi because, you know, can you guys see my screen and hear me?
Yes, sir.
Okay. So now we can also do the same thing here. This is the same as 2 sine of 2 degrees cos of 2 degrees. You can see that your theta in this case is 2, right? And then now that is 2. What is sine of 2 degrees? Sine of 2 degrees is k, right? And this one is k. And then cos of 2 degrees is what we got there. Is gonna be square root of 1 minus k squared. Remember from this graph here, cos of 2 is adjacent over hypotenuse. So it's this over 1. So that is the answer to that. Are you guys happy?
Yes, sir.
Okay. Let's talk about this one. What about this one? Sine of 172 degrees.
Sine of 180 plus 8.
Sine of 180 plus
Mm.
8.
Minus 8, not minus 8.
But then, I want to show you something what Karabo just said now. Karabo is saying is 180 minus 8. This is not wrong, Karabo. But the biggest question that you want to find out is, do you know any information regarding that angle of 8 degrees?
No.
Yes. So the 8 degrees will not help you in any way because your graph is in terms of 2 degrees and 88 degrees. So how can we express this? In terms of special angles, boundary angles, and the given angles.
But can't we like use like those special like rules with the double angles from yesterday where we say sine times 4 and then 2 degrees in brackets?
But 4 times 2, I mean, like is 8. So it's not, I mean, that will, or when you, that, remember you're gonna have to first do compounding something. I want you to see something here. Clearly, this becomes difficult to use special angles because it's 172 degrees. Ne? Because special angles is 30, 45, 60. So you can't say 60 plus any angle here that will give you 172 or anything. However, if you want to look at it, and boundary angles you can try, but then Karabo tried, he said 180 minus 8. But then here we have 2 and 88, right? How about we look at given angles? The given angles have is 2 degrees and 88 degrees. I want you to compare 172 degrees and 88 degrees. Now, divide that 172 degrees by 2. What do you get?
88.
You get what?
86.
No, I think there I made a mistake there. I was supposed to say 186 actually. I wanted to say 186 degrees there. Okay. If you divide that by 2, you can see that this is the same as sine of what?
88.
Sine of 2.
88. It's
2
2
times
times.
88 degrees.
88.
Then when you are here, this is a double angle. This is the same as 2 sine of 88 cos of 88. Where do you get sine of 88? You come to the graph. Opposite over hypotenuse. this adjacent over hypotenuse. Are you happy?
Yes.
There's background noise there. Please tell those people to greet us there. Okay, good. So now how do we get sine of 88? You can get sine of 88. Masesi, how are you? From this, ne? Masesi?
Yes, sir.
Yes, you must watch the yesterday's recording. I sent it to the group, and you must send me your email to the group as well, so I can add you to our classroom. Ne? Same with
Okay.
Tsika as well. Tsika, I haven't received your email. Okay. Okay, good. So that was the double angles for sine as well. Let's look at the question that comes next. Let's look at this one. So they are saying, get cos 25 if cos of 5 degrees is P. We all know that we have to first write the triangle, right? Always remember that this is always over 1. Okay, so this will be your 5 degrees. That will be your 90. That will be your 85 degrees. And then it's cos P. Cos is adjacent over hypotenuse. So we know all that, right? So what is the adjacent of 5 degrees is this side here. So that is P. And the hypotenuse obviously is this one. And you can use Pythagoras. You find another one, use Pythagoras. This is 1 minus P squared. Is there anybody who is unclear as to how did I get this side here? So anybody who's unclear, please tell me. If you use Pythagoras, you should get this side here. Everyone happy with this? How I get this? R squared, x squared plus y squared. R is 1, x is P squared, y squared. That is 1 minus P squared equals to y squared. You square root both sides, 1 minus P squared, and that's y. Right? Do you see that? Everyone, do you see that?
Yes.
Okay. Now, where they want cos of 25 degrees. Remember the rule, you can use special angles, boundary angles, and given angles. So how can we express 25 degrees in relation to the angle that we are given? Either combining it with special angles or boundary angles. I think this one is easy. Cos of 25. Can we
30 and
express
5.
what?
It's using the special angle. 30 minus 5.
30 minus 5. Okay. 30 minus 5, right? So this is the same as cos of 30 minus 5 degrees. And then we can expand this, agree? It's the same as cos of 30 cos of 5 degrees. This is there in your textbook or your work, your data sheet in maths. If it's minus for cos, that would be plus. And then that is sine of 30, sine of 5. So cos of 30 is a special angle, the same as root 3 over 2. Cos of 5, this 5 here we were given. Cos of 30 is a special angle. Cos of 5 is what we're given there. That is P. Plus, sine of 30 is a half. Sine of 5, we can extract it from this. We can see clearly that is opposite over hypotenuse. So that is root 1 minus P squared. Then this becomes root 3 P over 2 plus 1 minus p squared over 2. Then you can decide to say 2 over root 3p, oh no man, root 3p plus 1 minus p squared. Is anyone who's lost today? Is there anyone who's lost?
Mhm.
Okay. Let's look at the simple one. What about cos of 50 degrees? What is cos of 50 degrees?
45 plus 5.
You can do 45 plus 5. That's a good one there, Karabo. That's a good one. There's another one again that we can also do. That's very, very good. 45 plus 5, that's correct. Okay, let's do the Karabo one. 45 plus 5, that's correct. This is cos 45 plus 5 when you use special angles. Actually, this is a nice question. And then you can combine that. So this is cos 45, cos of 5 minus. Are you following there, Andisa? Masses?
Yes, sir.
Cos of 45 is the same as root 2 over 2 or 1 over root 2. And the cos of 5 is what you can get from your thingy, that is P, minus cos of 45 is also root, no, sine of 45 is also root 2 over 2. Sine of 5 is what we got from this opposite over her, hypotenuse. 1 minus P squared. Guys, are you following? If guys, any questions here? Any questions?
Sir, I have a question.
Yeah.
I use 40 plus 45.
You use what?
No, I meant to say, wait, excuse me for a minute.
So you used what? Let me just get that. Yes, Tika? Tika, can't hear you.
I
Can you
was
guys hear
thinking,
me?
sir, can you hear me?
Yeah.
I was thinking, what about we use 130 minus 45? 130 minus 45.
130
Yes. Minus 45.
minus 45. The question is 130 minus 45, what does it give us? What is 130 minus 45?
It gives us 35 degrees.
85.
It gives what?
85
85.
degrees.
Yeah, but then, oh, let me see. Oh, yeah, that's fine. Yeah. No, but then no. If it gives you 85 degrees, né? It gives you 85 degrees. But then what is the context of the question? In this question here, we are interested in 50 degrees. Do you see that?
Okay.
You see that? We want to get 50 degrees. Just give me a second, guys. Do you see that, Tika?
Yes, sir.
Okay. Tika, well, you answered there. So you have to be cognizant of what you are currently focusing on. Here you want to write 50 degrees in terms of either special angles combined together with the given angles, or you want to write these 50 degrees with either boundary angles in conjunction with the given angles, or you want to use the very same given angles on their own. This is very important, guys. This is very, very important. These are the steps.
Yes.
You either use special angles in conjunction with this? Okay, so can you guys hear me? Can you guys hear me?
Yes, sir.
Okay. Now, there is another one that I'm seeing here, guys. There's another approach that we can use. Actually, did I not make it? Oh, I did not make a mistake. I did not make a mistake. There's another approach that I'm seeing here, guys. There's another one that we can also apply as well. Right? There's another one that we can apply here. Which one is that? As far as 50 is concerned. Who wants to try? Which one can we use, brother? Ntsika? Ntsika?
So there's also 90 minus 40, I think.
But 90 minus 40, do you have 40? You don't have 40. So you don't know what 40 is. You know, yeah. Just give me a second. Okay. Another one that I wanted you guys to see, which was a bit tricky. Can you guys hear me?
Yes, sir.
Yes, sir.
Is the cos 2 times 25 degrees. Do you see that?
Yes, sir.
Do you see that, guys?
Yes, sir.
But
However, the
what about
tricky part about this one is that 25 degrees is not in this triangle. However, we did solve 25 degrees here. Cos 25 is that. However, it is very, very important for you to see this. We know that cos has 3 identities, right? It has 3 identities, right? In the name of cos 2. Cos 2 theta can be cos 2 squared theta minus sine squared theta, or it can be 2 cos squared theta minus 1, or it can be 1 minus 2 sine squared theta. Okay. So tell me, what must we do? So we need to expand this cos 2 25 degrees. Which of the 3 do you think we should use?
The second one.
The second one. Why do you think we should use the second one?
Because that's the information that we have cos like as
Exactly.
the
We know what
trigonometry.
cos 25 degrees is. So if we expand this to cos, we don't gonna struggle with the sine. And more especially because we don't have 25 degrees in the triangle. So we can't get that information from the triangle. But then in this case, because we have cos 25 degrees, it then becomes easier for us to then expand this cos 25 minus 1. And we know what cos 25 is. You can substitute that. Is what you have solved here. It's root 3p plus, and you don't have to simplify these things. They just want you to substitute squared minus 1. You can leave it here. Are you happy with the guys?
Yes, sir.
This comes from that. You see? Are you happy?
Yes.
Okay. Good. Good. Are we happy there? Are we happy, everyone? Are we happy?
Yes, sir.
Okay. Good. Now, I want us to quickly look at this one. This is the hard one. I don't like giving students this one, but it's a bit hard. And I hope you guys will see. It's very hard. And for this one, it's so sine of 80. Or let me do cos of, okay, but sine of 80 is too fine. Sine of 80. How do you think we can express sine of 80? Either using special angles with these angles given, or using bounded angles with the angles given, or using the given angles themselves.
So
What is sine of
sine of, it becomes cos 10 with the co-functions, and then from there you can just say cos, and then it becomes a double angle of cos 2 times 5.
True, 100%. That's correct. There's another way though that I wanted you to see, but then that is very correct, Londek.
The 85 minus the 5. Can you use that as well?
100%. 100%. 85 minus 5 degrees. Do you see that? Andy, so are you there? Do you see that you can write 80 degrees?
Yes, sir.
You can write 80 degrees using 85 and 5 degrees. You can say 85 minus 5 degrees. Okay? Or you can do what Londega said. So let's start with the Londega's approach. Londega says this is a complementary angle. We know that sine of 80 is the same as sine of 90 minus 10 degrees. And if you do reduction of this, sine of 90 minus 10 is the same as cos of 10. You guys might have remembered that sine of 80 is the same as cos of 10. Complementary angles. Masesi, are you there?
Yes, sir.
You don't even have to show this part here. Ne? You need to know that if I say sine of 50 is the same as cos of what? Sine of 40 is the same as cos of what?
50.
50. If I say sine of 2 degrees is the same as cos of what?
88.
88. You need to know these things. So that is cos of 10. So now that we're on cos of 10 degrees, so here we can apply double angle. Why? Because 10 degrees, we can express 10 degrees in terms of 5 degrees. Do you guys see that? We can express 10 degrees in terms of what? 5 degrees. Do you guys see that?
Yes, sir.
So this becomes cos of 2 times 5 in double angles. And then this, then we can expand it to any of the three. Any of the three. Ne? But then let's look at the cos. Do we have cos 5 degrees? So you see, you have cos 5 degrees is P. Ne? Cos 5 degrees is P. So I rather choose to expand this into a cos because I already have a given information about this. So that will be 1. No, that will be 2 cos squared 5 degrees minus 1. And then that is 2 P squared because cos 5 is P minus 1. That's the answer. Are you guys happy there?
Yes, sir.
Or you could have done what Garabo said. Sine of 80 degrees can also be represented as sine of 85 degrees minus 5 degrees. Where, so question is, sir, where do I get these angles? I get this angle, so I'm given this angle. And by virtue of me being given these angles, it then means that I can extract whatever information I want. Now, if I'm given sine of 5, I can get it from this. If I'm given tan of 5, I can get it from opposite of adjacent. So that's why using these angles is much more safer. But then again, I need to be consistent with the fact that 85 minus 5 degrees is indeed 80 degrees. Are you guys happy there?
Yes, sir.
So that is sine 85 cos of 5 minus sine of 5 cos of 85. Then you can substitute here, right? Cos of 85, sine of 85 is P over 1. So sine of 85 is P over 1. So that's P over 1. Cos of 5 is also P. Cos of 5 adjacent of hypotenuse is P. So that is P. P over 1, basically. That's what I'm saying. P over 1. Okay. Okay. Just give me a second. Just give me a second. Okay, guys, sorry about that. Okay. Anyway, you can take that as a break. Okay, so sine of 5 degrees, then we can take it from here. Sine of 5 degrees. What is sine of 5 degrees then? Mases, what is sine of 5 degrees? Mases, what is sine of 5 degrees?
Square root of 1 minus p squared over 1.
Okay. Square root of 1 minus p squared over 1. Correct. And this one? What is cos of 85 degrees? Cos of 85 degrees?
P, sir.
Cos of 85, not 5. Cos of 85. Cos of 85.
Square root 1 minus p squared.
Over 1. So basically that is just a square root of 1. Square root. So basically it's the same. 1 minus p squared. And then p over 1 is p squared minus, then when you square root this, you see, when you square root this times that, is square root, so square root times square root of the things that are the same inside, you get rid of the square roots, and then you're gonna be left with 1 minus p squared. And then you can simplify this p squared minus 1 plus p squared. Then you can see clearly that p squared plus p squared is 2p squared minus 1. That is the same as what we got there. Do you see that? Do you see that, guys?
Yes, sir.
Extremely important that we know and understand how to do these things. Okay. So let's look at other questions as well. I think these ones I gave you in the when we're still learning, you know. But maybe we can revise for those who were not here. They say simplify the following. Cos of 75 can be written as what? Who remembers?
Let's
Cos
sign
of 75.
25.
Sign off?
25.
Yes, but then I mean you don't know what sign of 25 is. So they give you this and they say simplify. I'm glad I did this. So you guys forgot.
Wait, sir, is it
It's
a follow-up?
It's not a follow-up question, it's just a question.
Oh, you
It's
can
just a
write
question.
it as a compound angle. Sorry, sir.
And wait, Masesi, how can you write this as a compound angle? So it's 75 degrees. What does that mean? 75 degrees, we want to write it as a compound angle. What is that?
What about 30 plus 35?
What? You are right, yes? Yes, Tiga? Tiga?
Sure.
Yeah, what did you say?
I was saying 30 plus 45.
Exactly, 45 plus 30. Right, so you are writing this in terms of special angles. Right? You write this in terms of special angles. And then, do you guys
Sir?
agree with me? Yes.
Is this a follow-up from the graph that we're doing, or is this just?
No. It's not a follow-up, it's just a question. It's like a question. Simplify the following. There's no follow-up, nothing. Okay. There's no follow-up, nothing. Are you happy there?
Yes, sir.
So this you can expand, agree? This then becomes cos of 45. I mean, like, I think all of us know how to expand this. Masesi, Andiso, Karabo, do you know how to expand this?
yes,
I mean,
Yes.
we do cos of 45, cos of 30, minus sine of 45, sine of 30, and then you apply your special angles, punch that in the calculator, put in the values, and then simplify. What about sine 15?
Sine 45 minus 30.
And then you can just compound this and solve it. Are you happy there, guys?
Yes, sir.
Everyone, are you sure?
Yes, sir.
And then this one?
We can use a reduction, like, and then we'll get 180 minus 75. I mean, yeah, 180 minus 75, and then it's the same as A, so.
That's correct. Or you can do what? That's correct, by the way.
60
Oh, you can do
plus 45.
exactly. Special angle 60 plus 45. Do you see that?
Yes, sir.
Everyone, do you see that? Mases,
Yes, sir.
okay. Now, disregard this thing of A. I don't know where it's coming from. Let's look at this one. Let's simplify this. What do you see?
So
Cos 45, cos 20, sine 35, sine 20. What is this, guys?
it's a compound angle. Sorry,
It's a compound angle of what?
Of course, 35
Does everyone see
plus
that?
20.
Yes,
Does
sir.
everyone see that this is a compound angle of cos?
Yes, sir.
Everyone?
Yes, sir.
Okay. So this is the same as cos and then 35. But then remember, if this is negative, that other the here it would be positive, it's not negative. That is plus what? Plus 20. Are you happy?
Yes,
Yes, sir.
Then this becomes cos of 55. You don't have to simplify cos 55 any further because I don't think we can. But we can, but I don't want us to. Okay, let's look at this one. This one is a bit let's look at this one. Do you see that this one you have sine 140, cos of 80, sine of 40, sine of 10. Do you guys follow?
Yes, sir.
So what must we first do here?
We must get like common angles.
We must
Okay,
convert all of these angles into like two common angles or some sort. But then, do you guys see that the 140 needs to be simplified?
Yes, sir.
140 can be written as what?
Sine
180
180.
minus 40. Someone may ask, say, why do I use 40? Because I have a 40 here. So I have some familiar angles throughout. And then you don't have an 80 here. Do you guys see that?
Yes.
You have a 10. But then what is cos of 80?
90 minus 10.
Yeah, but then let's use complementary angle. What is the complementary angle of 80? What is, okay, yeah, that's fine. Cos of 80 is the same as sine of?
Sine of
Sine of
10.
10.
Sine of 10. So this here would be sine of 10 minus cos of 40 sine of 10. Are you happy there? Or if you don't want, you can leave the 80 the way it is. It's up to you. You can say this is cos of 80 né, minus cos of 40 if you want. And then you say, change that sine of 10 to cos of what? Cos of?
80.
Cos of 80. It's up to you really. And then what is sine of 180 minus 40? That's quadrant number what?
Number 2.
So that would be sine of 40 cos of 80 minus cos of 40 cos of 80. Okay. So this does not reduce to anything. I think maybe there was some sort of a typo when they were setting this question. Let me see. Because you can see here, this angle here is 40. That is 40. All right. This is 80. That is also 80. Do you guys see that?
Yes,
sir.
sir.
Do you guys see that? So this does not correspond to anything. We can't do any reduction because, why am I saying so? It's sine 40 cos 80. We are supposed to have cos 40 and sine of what? Sine of 80. But then rather we have cos of what? 80. So this one we'll rather leave it from here. Okay, let's not simplify it further. Okay. Okay, double angles, we did do them. We did do them. And I've proven to you how these double angles work and all those things. Okay. Are you guys happy there?
Yes, sir.
Okay. So let's dive deep to these double angles here. Let's look at this. 1 minus 2 sine squared 15 degrees. Which double angles does this thing look like?
Cos.
The cos one. where theta is 15 degrees, right? So therefore, this is the same as cos of 2 times 15, which is the same as cos of 30 degrees, which is the same as root 3 over 2. Are you happy?
Yes, sir.
Are you happy? Okay. Let's look at number C. Number C, which double angle is this one?
It's also a cos.
But there is cos where theta is what? 75. So that is going to be cos 2 times what?
95.
75, which calls for cos of 150. But then 150 is always, it is a special angle, but it's some sort of like a hidden special angle. So what must you do? Masesi, how can I write 150 in terms of a special angle?
-180 minus 150 minus 30.
180 minus 30. So, and then this is quadrant number 1. And this, so which quadrant is this? Cos 180 minus 30, which quadrant is this?
Second quadrant, sir.
So cos is negative, so I'm going to say negative cos of 30. Then when I'm here, then this becomes negative what? Root 3 over 2. Are we happy? Are we happy?
Yes, sir.
Do you see this one as well? It's also a double angle. Cos one.
Mhm.
Are you happy?
Cos 5 degrees.
Cos 2 times 5 again.
Oh, yes, sir.
Now, I want us to look at this one. Let's look at this one. What about this one? Sine of 15, cos of 15. Which double angle is this one? I told you yesterday, those ones who attended. Remember that
It's the
sine,
sine
do you know that sine of
double.
2 theta is 2
Yeah.
sine of, is 2 sine of
Theta cos theta.
theta. So what about, so if I were to divide this side by 2 both sides, do you see that the half sine of 2 theta is equals to sine of theta cos theta? So in other words, even if you see cos theta and sine theta together, you must think of the double angle as well. So what is this equals to?
Equal to a half sine squared 15.
Half sine 2 of 15 degrees. I'm going to pause a little bit here. Who does not understand this? This can be a bit confusing.
I don't understand, sir.
Okay. Okay, but you're not there yesterday, but then it's fine. Sine of 2 theta is a double angle, or it's a double angle, wherein when you expand it, it gives you 2 sine theta cos theta. You will see this is actually a derived formula. You will see how we derive it. I show you how to derive this. It's a derived formula of some sort. Sorry. Now, this is 2 sine theta cos 2 theta. Ne? So, if I want sine theta and cos theta only on the side, I have to divide by 2. So when I divide by 2, this side will be 1 over 2 sine 2 theta. Then the 2, because I've divided by 2, is sine theta cos 2 theta. Why is this helpful? This is helpful under a circumstance wherein I only have sine theta cos theta. In this case, I have sine 15 cos 15, which is pretty much the same as saying sine theta cos theta. But then if I have sine theta cos theta, it means it's half sine 2 theta. So a similar principle would then have to apply here. Half sine 2 what? What is the theta in this case? 15 degrees. Do you see that?
Yes, sir.
Now, half sine of 30. And sine of 30 we know is a half as well. So that is 1 over 4. Are we happy? Are we happy there, guys?
Yes, sir.
Okay. Okay, we did all of these things, double angles. We did this classwork, we did that one, we did this one. And then we come to this one again that I taught you. Quite a heavy one. So now this is a serious one. Let's continue. Okay, let's do this one. Maybe what I can do is, let me give you this one as a classwork. Let me pause the recording. Yeah. This one will be your classwork. Let me pause the recording. Think about double angles, think about everything, really, you know. But let me see if they did ask you about double angles here. Yeah, they did. They did. Okay, I'm gonna pause the recording. When I continue doing the corrections, please. There we did carry on. So now, thank you. So that is, so this one we all, without a doubt, that is 1 minus k squared. Are all together there? Are all together? Guys, are all together?
Yes, sir.
Yes,
Yes,
sir.
sir.
Cos of 154, we want to write these angles here in terms of special angles or boundary angles. I'll repeat this, I won't get tired. So I'll write this in terms of boundary angles or special angles. So this then becomes cos of 180 minus what? Minus 26,
26.
right?
Mm.
Right? Right? And then this becomes then, it's quadrant number 2. So that is quadrant number 2. That's negative what? Cos of 26. So this then just remains negative cos of k, negative k, sorry. Are all together? Are all together?
Yes, sir.
And then cos of 206 is the same as cos of what? 180 plus what? Plus what?
Plus 26.
Plus 26. Is everyone there? And then this is the same as, it's quadrant number 3. Cos is negative in quadrant number 3. So that is negative cos of 26. And that is negative k. Are all together there?
Yes, sir.
And then
Yes,
I asked
sir.
that to do number f. Number f is the same as sine 386. I said if an angle exceeds 360, you subtract 360. Né? Right? Right?
Yes, sir.
If you subtract 360, you'll be left with sine of what?
26.
26 degrees. What is sine of 26, guys? Is opposite over hypotenuse. Opposite over hypotenuse. So that is 1 minus k squared over 1. Do you see a mistake, Karabo, there?
Yes, sir. I saw it.
Okay. And there I see you wrote 1 over k. The adjacent of 64 degrees. The adjacent of 64 degrees.
I give only a
Please don't make these mistakes, Karabo, in the exam. Okay. Let's look at number H. Number H is saying sine, they want sine of 64. It should be easy to get sine 64 if you have populated the triangle. If you have populated the triangle. If you have populated the triangle. Sine of 64 is opposite over hypotenuse. That is k over 1. Are you happy? Which is k, basically. Are you guys happy?
Yes, sir.
Yes, sir.
No, the
And then you have q. Yes, Tika?
please
Tell.
read me.
You want me to
Oh,
repeat?
on it. We didn't do H.
Oh, H.
Oh,
Oh,
okay.
yes, we didn't do H. Okay, so I'm going to do H now. I'm going to do H now. Oh, what was I doing? What was that one? That sign of 64. It was J. Okay. Okay. Let's do number H then. Sorry, I forgot. Okay, so the number H, which then gives us tan 566 degrees. So you want to first subtract 360, right? When you subtract 360, what are you left with?
206.
So that is tan 206. What is tan 206?
180 plus
With
26.
tan, always avoid using 270 and 90 with tan. Ne? So that is 180 plus 26. Do you see the carabo that there's no need to say sign of override that? Still okay though, but there's no need. This is called the number 3. So tan is positive equal to number 3. That's tan of 26. Tan of 26, you can write it from this opposite over adjacent. So that is square root of 1 minus k squared over k all together.
Yes, sir.
Okay. And then that's fine. Wait, guys, did we do the calculus with you? I haven't done calculus with you guys, ne?
Calculus, no.
Okay, we need to do that thing. Okay, now that's fine. And then let's look at number Q. What is Q?
A double
Q
angle.
is sine of 52 degrees. Did anyone see that's a double angle of 26 degrees?
Yes,
This is
sir.
the same as sine of 2 times 26 degrees. And then that we know can be written as 2 sine of 26 cos of 26. And we know what sine of 26 is. If you check in the diagram, is 1 minus k squared. This is k, and then you can leave it there. Are you happy?
Yes, sir.
And then r cos of 52 degrees. It's a double angle as well. It's cos 226. And then what can you do from there? You have to choose out of the 3. So I would choose the one that I'm given. I'm given cos 26, so I'm going to change it to cos. Right? Do you see that, guys? I'm going to choose the cos one because the initial information gives me cos. So to make sure I don't make mistakes, I'm going to choose the cos one. Not to say it's wrong to choose the other ones, okay? 2 cos squared 26, that is 2k squared minus 1. Is everyone following there? Because cos of 26 is k. Are we together?
Yes, sir.
Okay, good. So I want us to look at other ones that I didn't give you. Please don't forget, a sign of a negative angle is negative, ne? This will become negative sine of 26. And then you take the 26 from the thingy, from the diagram. This is will just become cos of 26 because it's positive. All right. The one that I want us to do, I want to look at another interesting question here. Let's look at this one. What is this one? What is this one?
Double angle Of
You
course.
see that this is double angle and that double angle of cos. You see that, guys?
Yes, sir.
Cos
Then
2
this is the
times
same.
13.
This is cos 2 times 13. And cos 2 times 13 is the same as cos of 26. Cos of 26 is k, right? This one, you don't have to compress it to anything because it's 2. You know what cos of 26 is. Cos of 26 is k, I get. So that is k squared minus 1. Is everyone following?
Yes,
Oh,
sir.
yes.
Oh, yes.
Okay. Then let's look at number v. Okay, v is more or less the same thing. But the number v is a bit fishy because it is a double angle, but then you have to be smart about it, right? You can see that you don't have 1 minus 2 cos squared 30. You have 1, you have this one. Let's start with this one. Do you agree with me that this is a double angle of cos? This one? 1 minus 2 sine squared 13. Do you agree? So this one here is the same as cos 2 times 13, which is cos of 26, which is k. But then, however, this is not the same as that. So what must we do?
We can
We
take
must
a,
then, you must take out a
sorry,
negative. If you take out a negative 1, you'll be left with what? A 2 cos squared 13 minus 1. Because this will be positive, that will change to a negative. And then now you have a double angle of a cos. Do you see that?
yes, sir.
Mases, do you see that? Sika, do you see that? And this song, Karabo.
Yes, sir.
Okay.
Yes, sir.
Yebo. This is the one that I was looking for. Okay, this is also a double angle of cos. I'm not going to go deep into this one. I want this one. Cos of 56. We don't have 56 here. We have 26, 64. Then how do we write cos of 56? Let me bring it here at the top so we can just see everything. Cos of 56.
Compound angle.
It's compound angle of what? Yes, Masis? Is it Andy so Masis who said that?
Roslondega, sir.
Oh, Londega,
30
yes.
and 26.
What?
30 and 26.
30 and 26. You see, Karab, you're saying the right things. So don't make a mistakes when you write, yeah?
Yes.
So you wrote 56 in terms of a special angle and 26 degrees. Right. Remember always, you're gonna have to write these angles in terms of their special angles, boundary angles, or they themselves alone. Right. Right. Okay. Now this is the same as, so you can expand this. Cos of 30, cos of 26 minus sine of 30, sine of 26, and then 30, cos 30 and sine 30 are special angles. These ones, you can take them from the diagram, then you are done. I'm not going to simplify that for you guys. Okay. Are we happy there, guys? Are we happy?
Yes, sir.
Let's look at sine of 71. What is that? Let me do it here as well. Sine of 71. I'm going to give you some time to think about it. To tell you the truth, I'm also thinking about it. Okay, now I know what the answer is.
46.
Is it not 45 plus 26?
Exactly, 45 plus 26. Do you see that? Everyone, do you see that? Therefore, this is the same as sine 45 sine 26 plus, no, why, what am I doing? Hey, cos 26 plus sine 26 cos 45. And then you can substitute, this is a special angle, you can just punch in the calculator. Cos 26 and sine 26, you can get them here, and then you simplify your work. Are we happy there, Andiswa? Okay. Andiswa, I'm gonna give you a responsibility to give me the answer for cos 86. Let me just do this. Cos 86. Okay, cos 86, what is it? This is your responsibility, Andy. So I think this one is easy, actually. Cos 86 is easy. How do you represent cos 86? In terms of the angles we are given, special angles and boundary angles. Andy, so are you there?
Yes, I'm still trying to figure it out.
Don't take your time. I'm gonna give you some 2 minutes. So 1 minute, actually.
Uh, 60 plus 26.
60 plus 26, okay. So that is cos, as long as you figure it out. And then this becomes a cos compound angle, cos of 60, cos of 26, and then minus sine of 60, sine of 26. And then all of that, you can take it from your diagram. That is your special angle, and then you are fine. Are you happy there, guys? This one I just taught you. I taught you this one now. This one. What is this one? Sine of 13, cos 13. What is that? Londeka?
Double angle of sine, but you divide by 2 or times a half. Times half.
Exactly. So it's a half sine 2 of 13. Because the 2 is not here. Ne? If this was 4, ne? Okay, I'm going to do the 4 one. Okay. Half sine 26. Right? And then sine 26 you can take from the diagram. If this was 4, everyone. What you want to do first, you want to separate the 2. So divide this by 2. This is the same as 2 times 2. Sine 13. I did this yesterday, if you remember. Why am I writing 2 sine 13s here? Cos 13, cos 13. And then this will then become a double angle of 2 sine of 2 times 13, right? So I'm only taking this part. This is what the double angles is, right? And the 2 remains there, and then I have that. Do you guys see what I'm trying to explain to you? Do you guys see that?
Yes, sir.
So,
And then there becomes a very, very important one. This one, they like it so much. Nah. This one, I'm gonna even do this. This one, I want to do it in its own page. It's not really that. It is important, can be difficult. Okay. I want you to think about it properly. Okay, now they say they want cos of 13. Do you see that we don't have cos of 13 there?
Yes, sir.
So how do you think we should solve this one?
So can't we just like do what we did with the previous one and just say that divided by 2, take cos of 26 and then just say it's k over 2.
No, we can't do that. It's the angle that's
Mhm.
divided by 2. So
So I see.
I see where you're going. Cos of 32, we all agree that cos of 32 is the same as cos of 26 divided by 2, right?
Yes.
But this does not mean that this is k over 2, no. Ne?
Yeah, yes, sir.
You are dividing the angle, you're not dividing the whole thing. So it becomes then a very difficult thing. So now let me teach you how you do this one, okay? Every time when you have an angle that is a half like this, you see, this is 26 is a half of 13. Ne? You work backwards from this one. Ne? You do this. We know that cos of 26, right, is the double angle of what? Cos of 26 is the same as cos of 2 times 13. Are we together there? Are we together there?
Yes, sir.
Do you see that?
Yes, sir.
Do you see that, guys? Do you see that, guys? Actually, every time when the angle that you are given is a half of what you are trying to solve, you work backwards. Cos of 26 is the same as cos 2 of 13 degrees. And then, now, we know that cos of 26 is k, right? Don't you know that? We know that it's k. I think we're given from there. Cos of 26 is k. You know this, right? This is k. Are you happy?
Yes, sir.
Are you happy? But then we also know this is a double angle. Cos 2 13, that's a double angle. So what is that? That is 2. So I'm gonna change this to a cos. Remember, this has 2 identities. It has 3 identities, but I'm gonna change it to a cos because I want cos of 13. That is 2 cos squared 13 minus 1. Do you guys see that? Do you see that?
Yes, sir.
And then here, you just need to make cos 13 the subject of the formula. Let's make cos 13 the subject of the formula. Then I'm gonna have k plus 1 equals to 2 cos squared 13. Ne? And then I divide by 2 both sides, it becomes k plus 1 divided by 2. Are you happy there? And then that becomes cos of 13. Therefore, squared, sorry,
Sir?
square root of, yes, k plus 1. Yes?
No, never mind, sir. I got it.
Okay. Now I'm going to give you a classwork. Let's look at number E. Right. Number E, they want sine of 13. So now, how are we going to get sine of 13?
We're gonna do like what we did here, but we're gonna say sine 26 is equal to sine squared 13. And then we're gonna
Okay.
work backward. Yeah.
Okay, so that is very, very good. But then let's use cos as a base at all times. Let's use cos 26, all right? Because you will see that if I do this one, let's see. If I do sine of 26, that's a good one, huh? It's the same as sine 213. Ne? But I know sine 26. Sine 26, I think, is root 1 minus k squared. However, this becomes sine of 13. I then have a cos 13 problem again. Do you see that?
Yeah. Yes, sir.
I have a cos 13 problem when I expand this. However, In an event that you already solved cos 13, it's still okay. Because cos 13, you know, is this, right? You know, is that. You
Yes,
see
sir.
that? So we can do that. So I'm going to do it in two ways. But this is an event wherein you have been told to solve this first, right? Are you happy?
Yes, sir.
So in an event that we already solved for cos 13, it is okay to solve it like this. Sine of 26 being equals to 2 sine 13 cos of 13. And then when you're here, we know what cos 26 is from the diagram opposite of our hypotenuse, which then gives us 1 minus k squared equals to 2 sine 13. Allow me to divide both sides by cos of 13. So if I divide this by cos of what? Cos of 13. Let's just also just divide it as by 2 as well. So I'm going to get rid of that 2 here, you know, then divide by 2 cos 13, then I'm left with sine 13. What I basically did here is I have sine of 26, which then is a double angle 2 sine 13 cos of 13. And then I want sine of 13. I don't want anything that doesn't do with sine of 13. Then I divide by 2 cos of 13. Then I'm left with sine of 13. However, I know what cos of 13 is what I just solved here. Therefore, this is the same as 1 minus k squared over 2. And what I just solved, the cos of 13 is k plus 1 over 2. This is equals to sine of 13. Are you happy, the guys? Are you happy?
Yes, sir.
Or,
Yes, sir.
or we can use cos as a base. That's what I like to do. So, because we know the nature of cos. Cos can be written in terms of sine or cos. So that is cos of 26 degrees, which is the same as 1 minus 2 sine squared 13. Okay, wait. Let me first write it in terms of a double angle. That is the same as cos 2 13, right? Which can also be written in terms of a sine minus 2 sine squared 13. However, I know what cos 26 is k, right? It's k, right? Therefore, I can make sine 13 the subject of the formula here. Take this to the other side, it becomes plus 1 minus 2 sine squared 13. And then divide by negative 2 both sides, it becomes k plus 1 over minus 2 equals to sine squared 13. Therefore, sine of 13 is equals to, yes?
Why is it k plus 1?
Oh, I took the 1 to the other. Oh, minus 1. My bad. Thank you. K minus 1 divided by therefore sine of 13 is square root of k minus 1 over minus 2. Are you happy there? Are you happy there, guys?
Yes, sir.
This part, when you're watching the recording again, is very, very important. Okay. Okay. So now, Masesi, please send me your email. And Tika, send your email as well. I don't know if Tika said you sent your email, right?
No, I haven't.
Okay.
So we can download these videos without watching, having data and watch them anytime. How send like an email?
So again, that email, what happens is you're gonna go to that classroom thingy. Again, you'll go to the classroom, and then what you will do is you will download the video. You can download the video from there, or you can watch it there with your data. So the best thing is, if you want to download, you can download them, but then I think just leave them there so that you don't chow your space or what, like treat it as a YouTube channel of some sort.
Okay.
But for now, watch the recordings, because then I only uploaded one video. I'm gonna start uploading the other videos during the course of the weekend, this weekend. Okay.
Yes, sir. So you said, what work are we doing, like with the physics?
We're doing work, energy, and power.